Hey guys, tonight we're going to chase something you've probably never caught and never will. It moves faster than anything you've ever seen, and yet it touches everything. Your screen, your eyes, the stars above your roof. We're talking about the mysterious, immovable, impossibly swift speed of light. And trust me, it's not just about flashlights or lasers. This speed is the ruler of the universe, the ultimate limit, the one boundary that not even the wildest dreams can cross. And, spoiler alert, you're not going to survive it. Not because it's dangerous, but because it's untouchable. You could spend eternity building rockets, warping equations, stretching wormholes, and still, light will always outrun you, smiling politely over its shoulder as it vanishes into the fabric of space-time. So before you get comfortable, take a moment to like and subscribe to the video, but only if you really enjoy what I'm doing here. And if you're still awake, I'd love to know, where are you listening from? And what time is it right now where you are? Now dim the lights, maybe turn on a fan for that soft background hum, and let's start our journey together. Tonight, close your eyes, or leave them half-lidded if you're feeling poetic, and imagine the whole universe wrapped in a quiet thread. That thread is the speed of light. It's everywhere and nowhere. It's what gives shape to space and rhythm to time. It's not just fast, it's the fastest anything can possibly go. Now here's where things get strange. The speed of light isn't just a big number, it's a cosmic rule book. Like gravity tells apples to fall, the speed of light tells reality how to behave. It defines what's possible and what's forbidden. You might think, well, if we just build a fast enough spaceship, but nope. Physics says no. Light has set the speed limit, and nothing, not you, not me, not your favorite sci-fi ship gets to break it. And yet, this isn't a punishment. It's a kind of balance. You see, light isn't just a show-off with a head start. It needs to be fast, because it's how the universe communicates. It's how you see things, how plants grow, how your microwave heats leftovers, how the stars tell their stories. If light were slower, everything would look wrong, feel delayed, maybe even fall apart. Strange thought, right? That every sunrise, every reflection in a puddle, every glimmer in your cat's eye, all owe their precision to this one number. 299,792,458 meters per second. It's not round, it's not pretty, but it's perfect. And it's not just light. That number is the speed of causality. That's a fancy way of saying it's how fast anything, energy, information, even gravity can move. Nothing outruns it, because if it did, cause and effect would break. You could see a light before it was turned on. You could trip over a rock that hadn't hit the ground yet. You could read this sentence before I typed it. Physicists love this speed like poets love metaphors. Not because they understand it completely, but because it's stable, uncheckable. Even when everything else is uncertain. Now, let's wander a bit deeper. Imagine you're floating in space. No sound, no air, just you and the stars. Suddenly, one of those stars explodes in silence. The light from that explosion won't reach you for years or centuries. But when it does, it'll hit your retina like it's happening now. Because light carries the now of the universe on its back. Without it, we'd be stuck in darkness, not just visually, but temporally. We wouldn't know what was happening anywhere, ever. The world would be mute. And what's weirder? Light's speed is the same for everyone, no matter how fast they're moving. That's not just a fun trivia fact, it's the key to relativity. When Einstein figured that out, he realized time itself had to be flexible to keep up. That's right. Time bends because light won't dot, so next time you're running late, you can blame Einstein and a very stubborn photon. We'll get to all that. The bending clocks, the squished space, the no going back frontier. But for now, let your mind just hover on this one impossible idea, that the universe has a maximum speed, and we already know what it is. And every second, your brain is dancing to its rhythm. You might be wondering how we even know the speed of light in the first place. After all, you can't exactly put a stopwatch on a sunbeam or ask a flashlight to pose for a speed camera. But the story of how humanity discovered light's velocity is ironically slow, messy, and full of stumbles, which makes it a perfect bedtime tale. Let's start with Galileo. Yes, that Galileo, the telescope guy, the Earth orbits the sun guy, the one with a lifetime subscription to house arrest. He actually tried to measure the speed of light using lanterns. Picture it. Two people stand on distant hills, each with a covered lamp. One uncovers his lantern, and when the other sees the light, he uncovers his too. They timed the delay. It didn't work. Turns out light is just a bit faster than two guys yelling now across a field. But centuries later, someone got lucky. In the 1670s, a Danish astronomer named Ole Rachmer made a weird observation while studying Jupiter's moons. He noticed the moons sometimes disappeared behind Jupiter a little later than expected, and sometimes earlier. And this wasn't random. It changed depending on Earth's position in orbit. From that, Rachmer concluded, light has a speed, and it's not infinite. That was the first time anyone even dared to suggest it. Fast forward to the 19th century. Hippolyte Fizeau, in one of science's most underrated party tricks, shined light through a rotating gear and bounced it off a distant mirror. Depending on how fast the gear spun, the light would either return through the gap or smack into a tooth. By adjusting the speed until the returning beam vanished, Fizeau could calculate light's travel time. The result? About 300,000 kilometers per second. Not bad for someone messing around with mirrors and clockwork. Then came Albert Michelson, who refined these experiments to absurd precision. He used spinning octagonal mirrors, huge distances, and mountain observatories. In 1907, he became the first American to win a Nobel Prize in science. And yes, it was for measuring the speed of light, not splitting atoms, not curing disease. Measuring light. It's humbling. All this effort, decades of mirrors, moons, gears, and guesses, just to pin down a number. A number that turns out to be a cosmic constant, the same everywhere, always, no matter who you are or how fast you're going. Which brings us to a fun historical fact. In 1983, the scientific community got tired of trying to measure light speed better, so they flipped the game. Instead of measuring the speed of light, they defined it exactly. 299,792,458 meters per second. Done. Locked in. From now on, the meter would be defined by how far light travels in a certain fraction of a second. Yep, light now defines our ruler. That's how deep this goes. And while we're here, let's take a weird detour. In the 1700s, Isaac Newton actually believed light was made of tiny particles he called corpuscles. Others thought it was a wave. For centuries, science ping-ponged between these ideas until quantum mechanics shrugged and said, why not? Both? So now we live with a light paradox. It's a wave and a particle. It's a ray and a ripple. It can interfere with itself, yet also arrive in single countable chunks called photons. If that makes your brain feel like jelly, you're not alone. And here's a debate still smoldering in academic corners. What is the medium light travels through? Sound needs air. Waves need water. But light? In the 1800s, scientists invented an invisible ether to explain it. Then Michelson and Morley disproved that idea spectacularly. Turns out, light doesn't need a medium. It carries its own dance floor. All of this is to say, light is sneaky. It's everywhere, yet impossible to pin down. It behaves like nothing else. And somehow, over the course of centuries, human beings, squishy, confused, stubborn creatures managed to not only notice it, but to measure it, define it, and build our understanding of the universe around it. That's where the real magic begins. Because once we knew the speed of light, we didn't just unlock a number. We unlocked time. You're lying in bed right now, hopefully tucked in, eyes heavy, limbs sinking slowly into the mattress. Now imagine for a moment that time isn't flowing around you like a river. Instead, it's bending, stretching, curving. It's not ticking forward, it's being shaped. And all of this is happening because of light. To tell that story, we have to step into the mind of a quiet, intense young man working in a Swiss patent office at the turn of the 20th century. He's not a professor. He doesn't have a lab. But he spends his lunch breaks thinking about what would happen if you could chase a beam of light. His name is Albert Einstein. He imagined, if I could ride alongside a photon, what would I see? Would the wave freeze beside me? Could I catch up with it? The answer led to something earth-shaking. No matter how fast you're moving, the speed of light stays the same. That might sound boring at first, but it absolutely shattered physics. If light's speed can't change, then time and space must change instead. They have to bend, give way, stretch out, and compress just to keep light obeying its law. And suddenly, the universe wasn't made of still frames on a film reel. It was a fluid, tangled thing called space. So what does this actually mean for you? Well, it means that time ticks differently depending on how fast you're moving. If you boarded a spaceship traveling close to the speed of light, time would slow down for you compared to your friends back on Earth. Fly far enough and fast enough, and you could come home to find everyone older or gone. This isn't sci-fi. It's been proven with satellites, atomic clocks, and jets. The faster you move, the more you stretch time. It's called time dilation, and it's the reason GPS satellites have to constantly correct for the fact that time passes differently for them than it does for us on the ground. And here's a historical gem. Einstein wasn't even trying to blow our minds. He just wanted Maxwell's equations to make sense. Those equations describe how light behaves as a wave, and they work only if light's speed is constant. Everything else followed from that: relativity, the merging of space and time, even black holes. But let's get a little dreamy for a moment, because the idea that space and time are flexible, responsive, and constantly reshaped by motion and gravity, that's haunting. You're not just in time, you're changing it just by existing. Your body, your heartbeat, your thoughts, all of them are flowing through a landscape that bends subtly around you. And light? It doesn't experience time at all. That's the weirdest part. Photons, the particles of light, travel at light speed, obviously, and because of that, they don't age. From the moment a photon is born, say, in the core of a star, to the moment it strikes your eye, no time has passed for it. It's instant, timeless. So every time you see the twinkle of a star, you're catching a message that left its source years ago, even millions or billions. But from the photon's perspective, it just happened. No waiting, no journey, just one step. There to hear, that sit with you. It means that light isn't just fast, it's beyond time. It's the only thing in the universe that travels like this. Everything else is stuck in time's web, crawling forward second by second. Light just slips through. And yet, it's not infinite. Light has a speed limit. It feels instant too. US, but it isn't. The sun's rays take about 8 minutes to reach Earth. The glow of Alpha Centauri, the nearest star system, takes 4 years. Light from the edge of the observable universe? That's a 13.8 billion year journey. But for the light itself? Blink dot. So what's the takeaway? The speed of light is more than a number. It's the heartbeat of reality. It's the one constant that holds all the variables in place. It's why time can dilate, why space can stretch, why gravity can pull. Not just matter, but the very clockwork of the cosmos dot. It's not just the fastest speed. It's the foundation dot, and Einstein didn't just reveal this limit. He showed us that within it, everything bends, and that bending is the most beautiful, poetic thing in all of physics. So now you're floating through this universe that bends and ripples, where time can stretch like warm taffy and space can fold itself into strange looping shapes. But here's where the story gets even more mysterious. Light isn't just fast, it's weirdly stubborn dot. No matter what you do chase it, run away from it, turn around and try again, it always travels at the same exact speed. And that's not just spooky. It's essential. This idea might seem counterintuitive because we live in a world where speeds add up. If you throw a baseball from a moving train, the ball's speed combines with the train's. But with light, doesn't matter if you're on a rocket ship, a bicycle, or lounging in a hammock under the stars, light still zips past you at the same exact speed. 299,792,458 meters per second. That's because light doesn't care about you. It isn't adjusting to your perspective. Instead, your perspective adjusts to it. That's the genius of Einstein's special relativity. Time slows down, space contracts, your clock ticks differently, all just to keep light moving the way it wants to. Imagine reality bending itself like a yoga instructor just to make light happy. That's essentially what's happening. And here's something even more fun. Because of this constancy, the faster you go, the slower time runs for you. That's not metaphor. It's testable, observable, measurable. In fact, we've done it. Astronauts orbiting Earth in the International Space Station are aging just a tiny bit slower than we are. Not enough to grow younger or get out of taxes, but still a measurable drift. There's even an experiment involving particles called muons. These little guys are created in the upper atmosphere by cosmic rays and only live for a tiny fraction of a second. They shouldn't make it to Earth's surface, but they do because they're moving so fast that time slows down for them. From our perspective, they're surviving longer. From theirs, the journey is much shorter. Both are true. This isn't just a math trick. It's the fabric of the universe reshaping itself, depending on how fast you're going. And it all comes back to light. Let's step into a thought. Experiment Einstein's favorite kind. You're on a train, moving near light speed, and you shine a flashlight forward. From your perspective, the light moves away at, of course, light speed. But now imagine someone standing on the platform, watching you zoom by. They also measure that beam speed as light speed. Not light speed plus your train speed. Just light speed. This sounds impossible. But it happens because each observer is experiencing their own time and space. The faster you go, the more compact your space becomes, and the slower your time flows, until everything reshapes just enough to keep light's speed constant. It's as if the universe says, okay, you want to go fast? Cool, but I'm going to bend everything else to protect this sacred speed. And yes, this creates weird consequences. Like the twin paradox. One twin stays on Earth. The other goes on a high-speed journey through space. When the spacefaring twin returns, they're younger than their sibling. That's not just a bedtime riddle, it's physics dot, and it leads to a mind-bending truth. There's no such thing as absolute time. No cosmic clock ticking in the sky. Time is local, personal. It depends on where you are and how fast you're going. Let that swirl around in your sleepy brain for a moment. Because when you think about it, that means your perception of now isn't shared with the rest of the universe. It's just yours. Right now on some distant planet, light is still traveling from the dinosaurs. On the far edge of the cosmos, some ancient explosion is just becoming visible. Your present is someone else's ancient past or their distant future. The constancy of light speed forces this weirdness. It demands that the universe not behave like a stage with synchronized clocks, but like a dance floor where each dancer hears their own music, all coordinated by the speed of photons. So next time someone asks what time it is, you could say, for me or for a spaceship circling a black hole. Just to keep things interesting, we're still not done with light's stubbornness. In the next leg of this journey, we're going to dive into how this speed limit shapes the very idea of causality. What can happen, and when? Because if you want to send a message to the stars, or to your future self, you're going to need to know just how far light is willing to go, and no farther. Alright, let's talk about cause and effect. It's a simple idea, right? You push the domino falls. You clap your hands, you hear the sound. Things happen because other things happened first. But what if time didn't flow the way we thought? What if the only thing keeping events from unraveling into chaos is the speed of light? This is where things get quietly wild. See, because nothing, not information, not matter, not even your most embarrassing memories can travel faster than light. The universe ends up with a built-in traffic control system for when things are allowed to happen. Physicists call this the light cone, and it's not made of ice cream. Picture it like this. Every time something occurs, say, you flick on a flashlight, a bubble of potential expands outward at light speed. That bubble is the region of the universe that could possibly know about your action, assuming it's obeying the cosmic speed limit. Anything outside that cone? It can't be affected by what you did. Not yet. Maybe not ever. That's the rule. Nothing gets to jump ahead in line. And thank goodness. Without that limit, causality would crumble. You could destroy the logic of time itself. Events could trigger other events before they even happen. It would be like watching a movie where the ending starts, playing before the opening credits roll. Confusing, messy, cosmic nonsense. But because of light's stubborn ceiling, the universe keeps its order. You can't signal across space faster than that. You can't influence things outside your light cone. You're boxed in, and that box is what gives your reality structure. Here's a mainstream gem. Einstein's theory of relativity doesn't just describe how time and space bend, it defines what counts as a possible event. The light cone sets boundaries. Within it, yes, maybe. Outside it, nope, not yet. So let's get speculative. What happens if something could break that rule? Well, physicists have toyed with the idea of tachyons, hypothetical particles that always move faster than light. The problem? They lead to time paradoxes. If tachyons existed, you could theoretically send a message into the past. You could warn yourself about your own mistakes. You could say, don't eat that leftover sushi before you get food poisoning. But if you change the past, you might erase the reason you sent the message in the first place. That's a causal loop, a paradox. And the universe, for all its mystery, seems deeply allergic to paradoxes. So far, no evidence for tachyons, no signs of faster than light anything. Not even with quantum entanglement, that weird spooky connection between particles. Yes, entangled particles influence each other instantly, but no usable information can be transmitted that way. It's as if the universe allows a kind of secret handshake, but no full-blown conversation. And that's the theme here. The speed of light isn't just fast. It's foundational. It's the universal referee, blowing the whistle whenever reality tries to cheat. So when someone says light is the fastest thing there is, what they're really saying is, nothing can outpace the structure of reality itself. And you, yes, you and your cozy bed are a tiny player in this vast, rule-bound system. Every action you take, every breath, every blink, is contained within a delicate latticework of possibility, shaped by that cosmic speed limit. We take it for granted, but it's amazing. Without the speed of light as a barrier, the universe wouldn't just be strange, it would be unwatchable. Like a movie with scenes out of order, where people answer questions before they're asked, and stars explode before they're born. So thank light for its limits. And while you drift towards sleep, consider this. Your thoughts right now are little electric sparks in your brain, zipping along your neurons, not at light speed, but still incredibly fast. Even thinking has a speed. And even thoughts are bound, ultimately, by light. Time feels linear, but that's only because you're stuck inside your light cone, riding the arrow of causality like a leaf in the current. There's no rewinding, no skipping ahead, only forward, and the light will always get there before you. Let's float even deeper now. We've talked about how the speed of light holds reality together like invisible threads pulled taut between the stars. But there's another side to this story, a side where light's speed doesn't just govern what's possible. It limits what's knowable. Because here's the strange truth. You've never actually seen the present. Not once. Every image, every color, every sparkle in the sky, what you see has already happened. Even the room around you, dimly lit and quiet, is slightly delayed. The light bouncing off your pillow, your wall, your reflection in a mirror, those photons took time to reach your eyes. Tiny, yes, but real. Look at the moon, and you're seeing it as it was 1.3 seconds ago. Glance at the sun, okay? Don't. But imagine and you're seeing it 8 minutes in the past. Peer into the night sky, and you're gazing into centuries, millennia, even billions of years of delay. The farther we look, the further back we see. That's because light takes time to travel. It's not instant, and so we live in a permanent time delay. Our experience of now is a stitched-together illusion, a projection, a lagging live stream of the universe. And yet we're used to it. It's our normal. Here's a mainstream gem. When astronomers study distant galaxies, they're actually looking back in time. A Hubble Space Telescope has captured light that left its source over 13 billion years ago. That's not a metaphor. That's literal. The images you see of deep space are cosmic memory, the universe remembering itself. And the fringe part? Some physicists believe that since we can only ever observe the past, the present might not even be objectively real. Just a blur between what we already know and what we can never quite catch. Kinda poetic, huh? It makes the present feel slippery, and light is the thing that keeps it that way. You're surrounded by echoes, delayed whispers, reflections of things that might already be different, gone, even by the time you see them. And if that doesn't give you chills, here's something else. The cosmic speed limit doesn't just stop us from seeing the present. It hides whole regions of the universe from us. There are galaxies so far away that their light will never reach us, no matter how long we wait. The space between us is expanding too quickly. Their photons are being stretched into oblivion, their messages forever lost in the widening dark. There are things out there we'll never know, not because we're not smart enough, but because light can't get here in time. It's like being stuck on a shrinking island of knowability, with the shores receding faster than we can run. And yet, despite all of this, you hold a kind of quiet superpower. When you look at the stars, when you really see them, you're performing an act of time travel. Your eyes are time machines. The light entering your pupils has crossed unimaginable gulfs, skimming past planets, dodging dust clouds, surviving the violence of gravity and heat and radiation, all to end its journey on your retinas. Think about that. Photon that left a galaxy before Earth even existed ends its journey in you. You are not just part of the universe. You are its destination. And the light? It never slowed down. It never took a break. It just kept going, faithful and fast and free, until it stopped. Right here, right now, in this soft moment, as you breathe, as you blink, as you listen to the hush of sleep begin to settle in your chest, remember that you're always surrounded by ancient travelers. Light from stars, from cities, from the people you love. All of it cascading through time to meet you in the stillness. And it's always moving forward, just like you. We've talked about how light is fast, how it keeps reality tidy, and how it gently filters what we can see and when. But now, let's talk about something that most people don't realize. The speed of light doesn't just rule the cosmos, it shapes your body. Yep, your squishy, dreaming, snack-loving self is bound bone, brain, and breath to this limit. Take your nervous system. Every time you feel something like a breeze brushing your cheek or the sharp betrayal of stepping on a Lego, your nerves transmit that signal using tiny electrical impulses. But those impulses don't move at light speed. They crawl along at around 100 meters per second in some nerves. That's about the speed of a bicycle. Not exactly warp drive, but imagine if they did travel at the speed of light. Every reaction you had would be instant. Reflexes, thoughts, movements, all perfectly synchronized. But there's a problem. Your body would be chaos. Everything would fire at once. No delays, no moderation, no buffering between sensation and response. And here's the funny part. Your brain already struggles to coordinate all this lag. When you stub your toe, the pain signal travels slower than the sound of your own scream. But your brain cleverly delays certain sensations, syncs them up, and makes it all feel like one smooth experience. It's doing constant edits, like a very tired film director trying to stitch together a coherent timeline from sloppy actors and late props. And still, light rules over all of it. Even your vision is governed by it. The time it takes for light to reflect off an object and enter your eyes. The processing delay as that light is turned into signals and interpreted by your brain. It's all happening in a staggered, carefully choreographed cascade. So when you look in a mirror, you're not seeing the real you. You're seeing you a fraction of a moment ago. And your brain just goes, yep, that's close enough. But let's scale this up. If light traveled faster or slower, your perception of the world would be completely different. The delays between cause and effect would either vanish or stretch into unbearable slowness. You'd see people's mouths move out of sync with their voices. You'd try to catch a falling cup, only to watch it crash in what feels like slow motion. Your reality would desynchronize. It turns out, the speed of light is just right for the size of human beings. Any faster, and you'd be overwhelmed with sensory noise. Any slower, and life would feel like a buffering live stream on bad Wi-Fi. This isn't coincidence. There's a compelling argument in physics that the constants of our universe, including the speed of light, might be tuned in a way that allows for life, at least as we know it. It's called the fine-tuning problem, and it's one of the most baffling mysteries in science. If light were even slightly faster or slower, atoms wouldn't form properly. Stars might not burn long enough to support planets. Molecules might not stick together. Basically, no people, no podcasts, no playlists. And here's where things tiptoe into the fringe. Some scientists suggest that maybe there are other universes out there, entire realities with different physics. In some, light is slower. In others, it zips along far faster. But in those universes, there may be no galaxies, no stars, no solid matter. Just chaos. Ours is one of the rare cosmic sweet spots where physics allows structure, balance, and maybe even sleepy YouTube videos like this one. So tonight, as you lie still and your breath slows down, consider this. Your ability to perceive the world, the softness of your blanket, The quiet hum of the air, the story you're listening to, depends entirely on the limits of speed. Your thoughts, your vision, your sense of now, they all operate in harmony with a cosmic pace setter that never compromises. The light that left the stars took its time to get here. So did the signals bouncing between your eyes and your mind. Nothing rushed. Everything perfectly delayed. And somehow, that delay is what allows you to feel it all. We're halfway across the universe now, wrapped in a blanket of starlight and questions. And it's time we ask something simple but dangerous. What if the speed of light isn't constant? Gasp, I know. Heresy, but let's tiptoe through it. In Einstein's special relativity, the speed of light in a vacuum is an unbreakable law. 299,792,458 meters per second. That number is sacred, fixed, immovable. It forms the foundation for everything from GPS satellites to the physics behind black holes. Mess with that number, and the whole cosmic house of cards might collapse. And yet, some physicists have dared to poke at it. Let's start with a mainstream shocker. In the early 2000s, researchers in Australia found evidence suggesting that the fine structure constant, a number that includes the speed of light, may have changed ever so slightly over billions of years, based on observations of ancient quasars. The idea? Light might have traveled at a different speed in the distant past. Now, that's still controversial. Most of the physics community said, interesting, and then immediately went back to double-checking their calculators. But the point is, it's being studied. Seriously. With math and everything. If true, it would mean that the rules of physics, our most sacred laws, may have evolved over time, like cosmic software patches. Maybe in the early universe, things were different, faster, stranger. Maybe light wasn't quite as strict back then. And that brings us to the fringe. Some bold theorists have proposed that a variable speed of light could solve some of cosmology's biggest headaches, like the horizon problem, why the universe looks the same in every direction, even though there hasn't been enough time for light to travel across it all and even things out. If light used to be faster, that would explain the smoothness. It's like discovering your house is evenly heated, but your radiators haven't been on long enough, unless once upon a time they worked 10 times faster. Mind-blowing. But what does this mean for you, curled up in bed right now? It means the universe might not be as fixed as we think. That what we call constants could be contextual. That maybe, deep down, reality is more flexible than we give it credit for, which makes you wonder if light can change, even a little. What else can? Maybe the passage of time itself isn't a fixed river, but a shifting stream. Maybe your experience of life, its rhythms, its patterns, its seasons, is shaped by more than just clocks and calendars. Maybe it's shaped by a cosmic tempo that we barely understand, because time and light are forever intertwined. One defines the other. You measure distance in time. You measure time in light. Astronomers even use something called a light year, not a unit of time, but a distance. It's how far light travels in a year. Even our sense of scale is bound to light speed. And here's a quiet realization. If light had no limit, if it were infinite, you'd see everything all at once. Every star, every event, every shadow cast from every direction. The sky would be blinding. There would be no such thing as darkness, no waiting, no mystery. But instead, the universe hides itself. Because light moves at a pace. It gives you mystery, discovery, moments. It lets the universe unfold like a story, not a data dump. You get a chapter at a time. No spoilers. And maybe that's the only way we can truly experience wonder. One light speed delayed, flicker at a time. So while some scientists argue about variable constants in faster ancient light, Maybe you can just appreciate the slowness, the patience, the idea that even the fastest thing in the universe takes its time. And as you slowly drift toward sleep, remember, everything you see, everything you know, is filtered through that ancient, glowing limit. Reality is slow, on purpose. And somehow, that slowness is what makes it beautiful. Let's zoom out for a moment. You're lying still. Your breath is slow. The room is dim. And around you, just outside your walls, light is always on the move. Streetlights shimmer. Stars blink from centuries ago. Distant galaxies whisper across incomprehensible distances. And every one of them obeys the same rule. Never faster than light. But why? Why can't anything go faster? It seems like such a simple question. If something's moving fast, can't we just push it a little harder? Add more energy? Rev the engines a bit more? Here's where the universe chuckles, leans in, and says, nice try. Because according to Einstein, and tested in experiment after experiment, when you push something faster and faster, its mass increases. Not just metaphorically, its actual measurable mass starts to climb. And to push more mass, you need more energy. The faster it goes, the heavier it becomes. It's like trying to sprint while dragging a growing pile of laundry behind you. Eventually, no matter how strong you are, you just can't. At the speed of light, the energy required becomes infinite. You'd need more energy than exists in the entire universe to accelerate a single particle past that limit. So the speed of light isn't just a suggestion. It's a wall, not a speed bump. A brick one, with alarms. And this wall creates a kind of cosmic speed trap. Everything inside our universe plays by this rule. No exceptions. Not atoms, not rockets, not thoughts, not dreams. No cheating. But here's the twist. Light itself doesn't need to accelerate. It was born moving at full speed. Photons, the particles of light, have no rest mass. So they're not weighed down by the same rules. They're like eternal gliders, sliding across space-time at full speed from the moment they exist until the moment they vanish. And because of that, photons don't really experience time the way we do. Let's pause there, because it's weird. If you were a photon, you're not. But let's pretend time wouldn't pass for you. You'd leave a distant star and arrive in someone's eye across the galaxy instantly, from your perspective. No waiting. No ticking clocks. Just origin and destination. In that sense, light is like a time-traveling messenger, immune to the very medium it travels through. But there's another side to this speed wall, because it protects us. Let's say there were particles that could travel faster than light. Theoretically, we call them tachyons. Fun word. Sounds like a candy from the future. But if tachyons existed, they'd wreak havoc on causality, the idea that cause comes before effect. You could send a message backward in time. You'd stub your toe before walking into the coffee table. Time would unravel. That's why the universe seems to defend light's speed so fiercely. Without that limit, physics becomes chaos. Causality collapses. Events no longer make sense. And in a weird, beautiful way, light's limit is what gives us the arrow of time. It assures that things unfold in a particular order. That you can remember the past, but not the future. That a dropped glass shatters, but never reassembles. That stars explode, people grow older, and your tea eventually gets cold. It's the backbone of reality's rhythm. So next time you watch a sunrise, or see headlights blur through a foggy window, remember those photons aren't just pretty. They're gatekeepers, guardians, enforcers of the rules that make your life coherent. Because if anything could go faster than light, time might not work at all. Got him for now. That's a bedtime paradox best left unexplored. So take another breath. Let your thoughts slow down. There's a soft kind of safety in knowing that some rules can't be broken. That no matter how chaotic life feels, light is always moving at exactly the same speed, across every vacuum, across every corner of the cosmos. And that's more than a fact. That's a comfort. All right, time to get cozy with another paradox one that makes your pillow feel a bit more like a spaceship. It's called time dilation, and it's not just a sci-fi gimmick. It's real, measurable, proven, and it all comes down to, you guessed, at the speed of light. Let's say you're on a spaceship. Lucky you. You've got snacks, chill music, maybe a cozy blanket, and you're zipping along at a decent fraction of the speed of light. Not quite light speed, because that's illegal in this universe, but let's say you're going fast enough that light starts to act differently. From your perspective, time feels normal. You listen to a full album, sip tea, stretch, nap. But back on Earth, things are moving differently. Maybe an hour passed for you, but years passed down below. That's time dilation. The faster you move through space, the slower you move through time relative to everyone else. And this isn't just theory. We've proven it. Mainstream example? The twin paradox? It goes like this. One twin stays on Earth. The other zooms off in a near-light speed rocket and then returns. Surprise! The spacefaring twin has aged less. Maybe they've got a few gray hairs. Meanwhile, their Earthbound sibling looks like they're ready for retirement. Same genetics, different clocks. The only difference was speed. And if that sounds too abstract, consider this. GPS satellites experience time differently than you do. Not by much, just a few microseconds a day. But if we didn't correct for that, your map would send you to the wrong street corner, or the wrong planet eventually. The satellites are moving fast enough, and they're far enough from Earth's gravity. That time actually ticks differently for them. Now here's a weird little fringe idea. Some scientists have proposed that time dilation could allow for interstellar travel, sort of. If you could move fast enough, you could travel thousands of years into Earth's future while only experiencing a few years yourself. In theory, it's a one-way ticket to tomorrow. A slow goodbye. You'd leave everyone and everything behind and arrive in a world that's forgotten your name got so much for. Postcards. But here's where it gets more philosophical. Time dilation means time isn't absolute. It's personal. Your version of now is slightly different than someone else's, depending on where you are and how fast you're moving. Even just walking briskly creates an infinitesimal difference. You could, technically, say that your foot and your head experience time slightly differently, which means, for a brief flicker of a nanosecond, your toe is younger than your forehead. We're talking microscopic differences, but it's real. Time is stretchy, malleable, dependent on your frame of reference. And if time is that flexible, then maybe, so is reality. Maybe there's no single universal present, just overlapping experiences, stitched together by memory and light. Maybe what feels solid and continuous to you is really a carefully edited perception, held together by your brain like a delicate quilt. This gives a kind of poetry to life. Every moment is unique, not just in feeling, but in physics. Your timeline is yours alone, and it's stitched into the universe with photons and gravity, and just enough cosmic delay to make it all feel continuous. But you know what's comforting? Number. Matter how stretchy time is, no matter how personal the now becomes, light still sets the rules. It holds the universe together like a calm metronome, ticking through space, bouncing off planets and mirrors and sleepy eyes in the dark. It says, I'll go no faster, but I'll go everywhere. So next time you feel like life is rushing past you or dragging too slowly, remember that time's tempo is part illusion, part reality. A dance between your brain, your speed, your gravity, and the light that touches. Everything. And tonight, as your thoughts gently drift, let that be a comfort. The universe is a little weirder and a little more wonderful than it first appears. And now we come to something deceptively simple. If light always moves at the same speed, no matter what does that do to space and time? The answer: it warps them. You might have heard of space-time, Einstein's grand unification of space and time into a single, bendy, cosmic fabric. Picture a soft trampoline stretched tight. Now toss a bowling ball onto it. That sag, that curve, that's what a massive object like a planet or a star does to space-time. It bends the grid. It tells nearby objects, "Hey, fall toward me." You're just following a curve. That's gravity, according to general relativity. And here's the kicker. Light follows those curves, too. Even though photons are massless, they still obey the geometry of space-time. When space-time curves, light curves with it. Like water flowing along the bends of a stream, light can be lured, trapped, even bent into loops. The most dramatic example? Black holes. These monstrous knots in space-time are so dense, they fold the universe in on itself. At a certain point called the event horizon, the curve becomes so steep, so deep, that not even light can escape. It's not that light stops moving. It's still going at full speed. It just has nowhere to go, but down. The speed limit still holds, but the path has been erased. So light's obedience to this cosmic speed limit doesn't just govern motion, it also shapes geometry. And that geometry, in turn, defines the structure of the universe. Want another trippy fact? When light bends around a galaxy, something called gravitational lensing, we can actually see multiple versions of the same star. One light beam travels one path, another follows a longer one, and by the time both reach our eyes, we see ghostly duplicates. That's not science fiction. That's astronomy. And we use it to map dark matter, measure cosmic distances, and peek into the early universe. And speaking of that early universe, let's talk about light's birth. The oldest light we can detect is called the cosmic microwave. Background, or CMB. It's the baby picture of the cosmos, released just 380,000 years after the Big Bang, when atoms first formed, and the universe became transparent enough to let light travel freely. Before that, the universe was a hot, dense soup, and light just kept bouncing around, trapped like a strobe in a fog machine. That moment of release, that was the universe taking a breath. And the photons from that moment are still reaching us. They're incredibly faint, stretched thin by 13.8 billion years of expansion. But they're there, wrapping around you now, humming gently through the night. You're literally surrounded by the whisper of ancient light, and it all still follows the rule. Never faster than light. Even back then. So now, lying here under your blankets, breathing quietly, think about this. You are tangled up in a web of light, some of it from nearby lamps and stars, some of it from the edge of time itself. Every photon follows the same rule, no matter how far it's traveled, no matter how much the universe has changed. There's something beautifully democratic about that. Light doesn't care if it's carrying your cat's reflection from a puddle or the afterglow of creation. It moves the same, predictable, loyal, limitless in reach, but never in speed. So tonight, as you drift further into stillness, let that constancy hold you. The laws of the universe don't need to shout. They whisper. Always the same speed. Always the same quiet rhythm. And in a world that often feels chaotic, rushed, and uncertain, that quiet promise might be just what your heart needed to hear. Now that we've wrapped ourselves in the soft glow of ancient light, let's do something bold. Let's imagine a world without the speed of light. Limit. Just for a moment. Let's imagine information, objects, maybe even people, could move faster than 299,792 kilometers per second. What would happen? It wouldn't be freedom dot. It would be madness dot. Because without the light speed limit, causality breaks down. You could send messages into the past. Flip a switch and cause a light to turn on before your finger touches it. Trip over a log before it appears on the path. The neat timeline you live in cause followed by effect starts to twist like a Mobius strip. A conversation might end before it begins. History itself would unravel. That's why light speed isn't just a speed. It's a boundary between past and future dot. We call it the light cone, a beautiful term that sounds like a dessert, but is actually the shape of causality in spacetime. Anything within that cone can influence you. Anything outside? Too far. Too fast dash untouchable dot. This limit defines your universe of experience dot. And here's something comforting. Even if the universe expanded faster than light like it did during inflation, right after the Big Bang, that wasn't a violation. Space-time itself can stretch faster than light without breaking the rules. But nothing within space-time can move faster than that sacred number dot. So what is it about light? Why this speed? Why not faster or slower? Nobody really knows dot. It's not. Like the universe picked it from a menu. It's just dot dot. What it is. A fundamental constant. A feature of how space and time stitch together. Light speed is the only speed that stays the same, no matter how fast you move. You could be standing still, riding a train. Drifting through space, light always zips past you at the same rate. That defies all intuition. It's why, back in the early 1900s, Einstein's ideas were so shocking. Before him, people thought time and space were absolute. That clocks ticked the same for everyone. That rulers stayed the same length. That light was just another kind of wave. But it wasn't dot. It was the benchmark. Every other measurement of time, of motion, of space, had to warp and stretch and flex to accommodate the unwavering constancy of light. In a way, we don't live in a universe with light in it, that we live in a universe defined by it. Take colors, for example. The only reason you see red or blue is because photons move in waves with different frequencies. Your brain turns those vibrations into experience. Faster waves equals blue. Slower equals red. Without light, color wouldn't just be gone, it would be meaningless. Take time. The seconds ticking by in your mind are measured by the speed of light bouncing inside atomic clocks. Take space. Distances between stars are measured in light years. How far light travels in a year. Without light, we'd have no sense of where we are or when we are. We'd be floating in a blind, silent abyss dot. So as your thoughts slow and the room gets quieter, remember, the reason anything makes sense at all, the reason you can see, measure, remember, and dream is because of this one limit, this one speed, this one cosmic agreement. Dot. The speed of light isn't fast because it's moving quickly. Dot. It's fast because it holds everything else together. Dot. And as the world around you dims and softens, that knowledge can be a kind of lullaby, a soft, whispered reminder that even in the vast, cold distances of the cosmos, there is order, there is structure, there is a rhythm that never changes. And tonight, you are part of that rhythm. Let's go a little deeper, now into the silence between the stars, where light travels undisturbed for billions of years. That gentle starlight you see twinkling in the sky, it may have begun its journey before humans even existed. You're not seeing those stars as they are. You're seeing them as they were. Some of them may not even exist anymore. They've burned out, collapsed, or exploded, but their light is still racing toward you, carrying ancient news across a dark, vast sea. Light is the universe's memory, its diary. Every glowing speck in the night sky is a delayed whisper from the past. This delay isn't just poetic, it's measurable. Astronomers build entire timelines based on how far light has traveled. The further away a galaxy is, the older the light we're seeing. It's like flipping through a cosmic photo album in reverse, page by glowing page. And it doesn't stop with stars, not every reflection, every shimmer, every shadow. These are moments sculpted by light. Your entire visual world is a carefully choreographed ballet of photons bouncing off matter, filtered through atmosphere, bending slightly around edges, slipping into your eyes with perfect, effortless grace. Your brain? It's not receiving reality in real time. It's receiving light and making its best guess. Even the mirror you looked into earlier today didn't show you now. It showed you a version of yourself that was nanoseconds old. The delay was tiny, too small to notice, but it was there. Light had to travel, reflect, bounce, and be interpreted. You are always looking into the past, even when the delay is just a breath. And it's not just time, it's color too. You know how sunsets glow with warm reds and oranges? That's not a special paint the sky puts on. It's light slowing down, scattering through air. Blue light, being shorter and friskier, scatters out first. Red, heavier and smoother, makes it through. So every sunset is not just beautiful. It's a live demonstration of Rayleigh scattering, and a quiet reminder of how sensitive light is. To the world it travels through. And light doesn't travel only in straight lines. It can reflect, bend, interfere, diffract. It can create illusions, like the shimmering haze of a hot road or the soft blue of a distant mountain. It can hide things like black holes or reveal them through clever tricks of infrared and X-ray detection. Of course, light can be broken into rainbows, those casual, dreamy arcs that curve across sky and storm. But each rainbow is yours alone. The light you see is bouncing off droplets in exactly the right way to enter your eyes. No one else on Earth sees the same one. The same applies to the northern lights, those ghostly curtains of color in polar skies. They dance because charged. Particles from the sun are colliding with Earth's magnetic field, shaking loose energy, releasing light in rare, otherworldly hues. They're a reminder that even violent solar storms, magnetic shocks, can become beauty if you know how to look. And we haven't even mentioned bioluminescence, the blue shimmer of plankton in the ocean, the warm flicker of a firefly in summer grass. These are living things making their own light, bending chemistry into glow, weaving biology and physics into quiet, glowing magic. So what does this all tell us? That light is not just fast. It's expressive, responsive, emotional. Almost. It carries stories from the edge of the universe and the tip of your nose with the same precision. It never stops, never rests. It just travels until it touches something, changes direction, or fades into background noise. Tonight, as you lie here with your eyes gently closed, you're bathed in light you cannot see. Radio waves humming quietly through your walls. Infrared. Warmth rising from your skin. A few old photons from the stars, bouncing off your curtains, mingling with the soft hum of your phone. The universe is not silent. It's glowing. And that glow, moving at a speed it never exceeds, is gently writing your story into the fabric of space. One wave at a time. And now, we arrive at the quiet edge of it all, the final moments of light's long, impossible story. Let's ask something simple. Will the light ever stop? In some far future billions of years from now, our sun will die. Its core will shrink. Its outer layers will drift into space, and what's left behind will be a white dwarf. Small, hot, glowing. Even then, it will still send out light. Not in the golden, radiant beams you know today, but in slow, pale flickers. The twilight of a star. But even that won't be the end. The universe, as we understand it, is expanding. Not just drifting apart, but accelerating, pulled by something we call dark energy, a mysterious force no one truly understands. And as galaxies race away from each other, their light stretches, wavelengths lengthen, redshift increases. Eventually, that light becomes so faint, so long in wavelength, that it drifts into invisibility. One day, far beyond any human lifespan, the sky will go dark, not because the stars are gone, but because their light can no longer reach us. The light will still exist. We just won't be able to see it anymore. That's not science fiction. That's a prediction based on the very laws light has always obeyed. Now, lean in just a little closer, because here's something poetic to sleep on. Even when you turn off the lamp, even when the last ember of your campfire fades, light doesn't die. It just keeps going. Every photon your room emitted tonight will fly outward forever, through the walls, past the clouds, into the cold cradle of space. Long after you've stopped breathing, after the last human story has been whispered into dust, the light we made will still be traveling. Every campfire, every lighthouse, every telescope glint. It's all still out there. You are luminous. Not just metaphorically, literally. Every second, your body emits light, faint, infrared, unseen, but very real. Your heartbeat flickers it. Your breath stirs it. The warmth in your fingertips ripples it. Even your dreams give off a quiet radiance. And tonight, as you fall deeper into sleep, you can take comfort in this. You are part of a great, glowing dance. A universe stitched together by light, stitched together by limits that are not restrictions, but rhythms, patterns, foundations. The speed of light isn't fast because it escapes things. It's fast because it connects everything. So close your eyes now. Let go of the weight of time. You are safe here, floating softly through a universe made of light and silence, structure and drift. And even when the story fades to black, that last photon will keep going across space, across memory, across the curtain of sleep. Let it all go now. Let the spinning equations and glowing particles drift quietly into the background, like fireflies dimming beneath a deep blue sky. The questions about time, about motion, about the speed that governs everything, they've all been asked. And for now, it's okay if they remain unanswered, because sometimes wonder doesn't need an ending. It just needs a place to rest. Tonight, you've walked along the very threads that hold the cosmos together. You've followed beams of light from your bedroom to the edge of the observable universe. You've imagined the birth of stars, the hush of ancient photons, and the gentle hum of laws that never change. And in all of that, you've remained still, softly breathing, calmly watching, like a lighthouse at the center of space. The speed of light may be nature's speed limit, but it's also a lullaby, a slow, constant pulse that wraps the whole universe in order and calm. It holds galaxies in their spiral arms. It balances equations. It bends around planets, dances through leaves, and glows softly in the warmth of a candle. And now it cradles you. So breathe in. Let the world dim. You are not racing. You're drifting. You are not behind. You're exactly where you need to be. The night will carry you now. And when you wake, the light will still be traveling, just as it always has.